Okay, it's been a while. But I never did Time Zone 2's Paper 2 for the May 2021 session. So this is a YouTube exclusive, just because, well, I don't know. I'm avoiding Twitch for now. But anyways, I'm going to do this because my kids are going through it right now and they want to see a solution set. So I'm going to do that. It's been a while. Hope everyone's doing okay. I'm alright. And here we go. So like I said, this is Time Zone 2's Paper 2 for the May 2021 year. So, I don't know. Let's just get started. Okay, we got a cafe. We have X and Y. We're going to make a linear regression. So we can pull out our handy dandy calculator. And we are going to, turn it on. And we're going to edit our list. So I'm using a TI-84, so maybe the way that I do it won't be the same as the way you guys would do it. But let's see, we got 3, 9, 11, 10, and 5 as my L1. That will be my X values. And I have 6, 10, 12, 11, and 6 as my Y values in L2. And then I'm just going to press stat, move over to the calculating section, and we're going to just do, linear regression. So the way that they want it is they want my x's to be the independent variable, so it's the variable that I plug in, and then y would be the dependent variable. So make sure my x's are, the x's in the thing, so that's L1, my y's are my L2's. And we're just gonna calculate this. And then here we go. Here's my A, B, and also my Pearson's correlation coefficient. So write down the value of A. A is 0.805. B is 2.88. And then for paper 2, we will be using, for math, always 3 significant figures or exact values, but these aren't exact values, so we're just going to round to 3 significant figures. Okay, what's next? Pearson's correlation coefficient R, so that's 0.978. Easy enough. Okay, interpret in context the value of A for part AI. Okay, so if you look at the format of the equation, y equals ax plus b, this A value is essentially our gradient or slope. And, in other words, if you apply that to data that has units, this is your rate of change. So if we were to graph these, we have number of customers as my X value, and my Y value is waiting time, Sarah's waiting time. So my rate of change is delta Y over delta X. In other words, this is Sarah's waiting time per customer. A is the waiting time. Per customer. So 0.805 minutes per customer, because I think, I don't know if this is in minutes, but yeah. So that's just context. Okay, and then the other day, Sarah visits the cafe to order a coffee. 7 customers have already ordered their coffee. Use the result from part AI to estimate Sarah's waiting time. Okay, so we know that X is 7, so we're just gonna plug this into our linear regression formula. as my x value. And then we're going to see what the waiting time will be. And maybe this calculator has a better way of doing this, but I'm just going to type this all out. So 0.805 times 7 plus 2.88. And then we're going to round this to 3 sig figs, so 8.52 minutes. Do they tell you? Oh, it is in minutes, yeah. Okay, yeah, first one done, not too bad. And then the second one, so let's see, let me just copy it over. Okay, we have a really weird function, we gotta sketch the graph. Okay, easy enough to do because we have a graphing calculator. So I'm just gonna literally type this in as I see it. So 3x minus 4 to the power of all of this stuff. 0.15 x squared x squared. And then, yeah, I think that's it. And then they want to graph it from 0 to 3. And then if you look at the window they kind of give you, this will help us format our window. So I'm going to make this go from -1 to 4 as my x's, similar to this one. And then my y minimum, I guess it's -3 to, I don't know, let's say 6. Okay, graph. Okay, here you go. Now, keep in mind that we do only want to graph this for the specific domain that they have, 0 to 3. So I'm going to be graphing it from here, which is at an x value 0, till here. Now, depending on how specific they want it, you might need to know what the y-intercept is and this x-intercept, and also maybe this value here at 3. So we can do all of that using calculating. So if I want to find that x-intercept, I can do 0, and then this one, it's annoying, but we're going to move our cursor to the left of our x-intercept, move our cursor to the right, and then this is telling the calculator where to look, and then it also wants an approximation. So 0.34 is where this x-intercept is. So now I can kind of roughly place it, I don't know, here. Oops, not a highlighter. Right about there. If you want to find the y-intercept, then just plug in x equals 0, and what you'll have is you'll have 3 times 0 minus 4 to the power of 0.15 times 0 squared. So essentially this is 0, this is going to be 1, so -1. So here's my y-intercept. They probably would like to see the maximum as well, so we're going to go back and calculate the maximum. And same process, it's going to ask you for a left boundary, the right boundary, and then a guess. So we have a maximum at 2.3 and about 3.9. So here at 2.3, we can go to 3.9, which is like here, I guess. And then lastly, we want to find out the y value when x is 3, because I just want to have an accurate endpoint. And that's also a calculating function, that's just value. And if you want to tell it, okay, what's the y value when x is 3, you can just say that and it'll go right there. So 2.5. So when the x value is 3, you got 2.5. And then this is pretty good. There you go. And I'm just gonna... well, it's too late now. But here's your sketch. Okay, next up. Find the value for which the derivative of your function is 0. So if you guys forget, this is our tangent gradient. So if your tangent gradient is 0, then that means that your tangent line is horizontal. And that is going to happen at the maximum point, which I kind of drew poorly, but right there. So at our maximum, the tangent line will be horizontal, and so we just need to find out what that x value was. And I forgot what it was. It was like 2.33 or something. But again, it's just the x value of the maximum point. And I think that's the end of that question. Move on to the next. Sorry that copying and pasting is taking a while. I actually haven't used my writing pad in a while, so it's low battery. And I only have 2 USB slots, so I had to unplug my keyboard. So I have to click to copy and paste instead of using keyboard shortcuts. Oh well. What do we got? Arithmetic sequence has the first term 60, common difference -2.5. Given that the kth term of the sequence is 0, find the value of k. Alright, so we can just use our UN formula. So UK, we know that this is 0, and we know that this is U1. Well, actually, let me just write it up here, the general formula. Okay, so U1 is 60, this is going to be k minus 1, and then our difference is -2.5. Okay, and then from here you can solve for k of various ways. We can algebra stuff, so I can subtract the 60 to the other side. I can divide over the -2.5. I don't really want to think about this right now, but I guess that's what a calculator's for. And then after I divide over the -2.5, I can just add 1, so +1, so that's k. Okay, from here, what is this? 60 divided by 2.5, 24 plus 1, 25. Okay, so the 25th term in this sequence is 0. Excuse me. Okay, and then Sn is gonna be the sum of the first n terms of the sequence, sure. Find the maximum value of Sn. Okay, so Sn has its own formula. It's n/2 bracket, and then there's 2 versions of it. Again, let me just write it out. So there's n/2 u1 plus un, and then there's n/2 2u1 plus n minus 1 times d. Okay, and depending on the context of your question and what values you know, you're going to pick one over the other. For this one, I don't have any information about the last term, so I'm going to be using the second one right here. So 2, and then I know that u1 is 60 already, n minus 1 times d. Okay, now we want to find out when this is going to be a maximum, and that will depend on how many terms we're adding. And with a paper 2, you don't need to use calculus and optimize it. You can literally just graph this as a function and let Sn be your y values and let n be your x values. which is exactly what I'm gonna do. So clear out that one. So it's x divided by 2, gonna multiply by, well, 2 times 60 is 120, plus bracket x minus 1, oops, forgot the 1, times negative 2.5, bracket, double bracket. So more or less just typing it as I see it. And then probably should change our window a little bit. X value are the number of terms, so I don't know, let's just do 20 to be safe. And then I have no idea how large it can go, so I don't know, 50 maybe? Okay, my window's way off. But as you can see, it's not high enough. Okay, we're changing this some more. 100? Still not enough. The other way you could do this quickly is with the equation solver, but I hate the equation solver. I'd rather just play around with the window for a little bit. I guess it's not that efficient though. Oh. Okay, I need more terms, so let's do 50. There you go. We have a maximum. So from here we can calculate what that is. Left bound, right bound, guess. And maybe I messed this up then, but find the maximum value of S. Notice that the actual maximum value is if we were to consider n as like a decimal or any number, and n realistically is only going to be whole numbers because it's the number of terms you have. So if I did this properly, which I'm a little questioning because I was hoping this would be like an exact whole number, well, I'm just gonna reason with you why it might not be. So what we need to do is we need to compare the sum, which is the y value, when it's 24, and also the sum of the y value when it's 25, just to see which one's actually larger. So for that, I can tell it what x value I want, which is, the first one's 24, so 750. So when you add the first 24 terms, it's going to have a sum of 750, and I'm just going to compare that to the 25th term, which is also 750. Okay. Oh, it doesn't matter how many terms, they just want the maximum value. So the maximum value is 750, because whether you add the 24th or the 25th, oh, because the 25th we saw earlier was 0, it makes no difference. The maximum sum is going to be 750. So Sn max 750. That's a little tricky. Okay, next. Okay, at a school, 70% of the students play a sport, 20% of the students are involved in theater, and then there's 18 that do neither. Okay, so right away, I'm gonna make a Venn diagram. We got our jocks, our sporty people, and we got our weird theater nerds. Theater people are so weird. Okay, and then it also says that 18% don't do anything. So obviously this is out of 100. So between both the sports and theater people, there should be, well, the difference between 100 and 18. So what is that? 82? And this is not like set notation and, this is like colloquial English and. So all the people in S and in T, there are some people that are in both. that should be 82% because again 18% aren't doing any of them. Now the funny thing is that if you add the percentages of the sports players and the percentages of the theater people, that's 90%. So there is an overlap, and we're double counting people. There's people in sports, and obviously there's people that are in theater at the same time. And that is just the difference between the two. There's 8%. And then from there, we can find out the people that only play sports. So that would be 70% minus the 8%, which is 62. And likewise, take the 20% of theater kids and then take away the 8% that are also in sports, which is 12. Okay, now we can answer the question. Find the probability that a student plays a sport and is involved in theater. We literally just found that out. That's 8%. Find the probability that the student is involved in theater but does not play a sport. Like I said, because we filled out the Venn diagram, I know that that's 12%, right? This represents the theater kids that aren't taking a sport. All right, now, at the school, 48% of the students are girls, and 25% of the girls are involved in theater. Okay. A student is selected at random. Let G be the event, student is a girl. Let T be the event, student is involved in theater. Then we need to find out the probability that the student is a girl and at the same time in theater. Oh boy. Okay, I need to think about this. We might need our formula book. And in case you haven't noticed, I'm going into this blind. I have not looked at this at all, so we'll just see how I do. I mean, you're getting this help for free, and you're getting what you pay for, so. Okay. Student is a girl. Student is involved in theater. I'm just writing out this formula, which is in your formula booklet, the one about unions. Maybe I should have looked ahead of time. But then I feel like it's not like an honest thing, you know? Anyways, the reason why I write this formula is that it does have this specific part that I am interested in. And I do know what these two things are, right? It's the probability of being a girl, which is 48. Probability of being theater. So I'm just going to put these values in. This is 0.48. This one right here is theater people, which is 20. And then we want to find out this, and then we know this. 25% of the girls are involved in theater. Am I being dumb? This is the girls that are in theater, right? Is this not 25? Maybe I don't need this formula. This is why this was weirding me out. Okay. G intersection T are the girls that are in theater. Is that not this? 25% of the girls are involved in theater. We'll come back to this. But anyways, determine if the events G and T are independent, justify your answer. So independence means that when you do have an intersection, that this probability, which you find in part C, if they are independent, means that if you take the individual probabilities of being, I guess in this case, a girl and being in theater, they need to be equal. And then if they're not equal, then that means that they're not independent. Of course, this does rely on your answer from part C, which is kind of tripping me up right now. But if this is the answer, this is 0.25, that I don't think you get from multiplying 0.48 and 0.2. And then if that isn't the case, that the two are not the same, then it's dependent and it's not independent. This one's weird. I don't know. I'm gonna leave that for now. My probability stuff is a little rusty. Actually, there's a mark scheme, so let me open that up. Okay, what question was that? Number 4? Come on. Okay. Here, let me show you the mark scheme. Why does that zoom in so much? Okay. Number C. Oh, okay. I thought this might have been the case. So let me explain what this mark scheme says. We'll revisit this one. So ignore this one. This is all not quite correct. Like I said, you're getting what you pay for. So this is the probability of being a girl. Now this says 25% of the girls are involved in theater. So you already know that they are girls. And this is the probability that they're in theater. So in other words, this is a conditional probability. Right here. And yeah, probably should have saw this coming. It was something that I thought of, but I didn't know if they were gonna do it like this. So again, 25% of the girls, like you already know they're girls. And this is the percentage of them that are in theater. And we want to find this out, and there's actually a formula that connects them all together, the conditional probability formula. And if we were to follow that, it looks like this. And, you know, T intersection G is the same as G intersection T, so we would just multiply this over here. Multiply this over there, right? I keep forgetting I don't have my keyboard plugged in, so I can't just press delete when I select stuff. Yeah, to figure this out. All right, so then that's as easy as doing 4d8, well, 0.48. Times 0.25. And then you'll get whatever this should be. So 0.12. So 0.12 is not the same as, well, 0.48 times 0.2. So that means that these are dependent. Yeah, oh, thank goodness. You know, when I was doing the other ones, I got them like fresh after all the students wrote it, so I didn't have a mark scheme, but now I do. Okay, on to the next one. You got two functions f and g, here they are. Find the range of f. This one. Okay, easy enough. We can graph it. So let me just type that in. 6x squared minus 12x plus 1. And then my window is really wonky from the last one. So if you don't really know what values to start with, you can go into zoom, and if you choose Z standard, then that resets it to -10 to 10 and then -10 to 10. Okay. So the range of this graph is basically the y values. So this has a minimum, therefore we'll need to calculate what that minimum is. And like I said, GDC, easiest way to do this, just let the GDC do it. So the minimum y value is -5, so the range of f is greater than or equal to -5. Okay. Now, we are going to do a composition. We're going to put f inside of g, and then we'll go from there. So f is inside of g. Okay. So I'm taking this expression and I'm putting it into the x value of g. And then what it's saying is that this new function needs to be equal to or less than 0. In other words, if you were to graph this, the y values need to be negative. So, or 0. So in other words, the graph is going to be entirely like below the x-axis. Okay, so how are we going to do that? Notice kind of the structure of this. This is going to be a vertical transformation. It's moving the graph up and down, vertical translation. And what we've done is we've reflected oops, spelled that wrong. This is a reflection, vertical reflection of our original graph. So there's two ways to do this. I'm just doing this the technical way first. So from part A, I know that this is -5 and up, right? If I vertically reflect it across the x-axis, then it's going to be looking like this. And it's going to be 5 and lower. Now notice that, like I said before, we want to vertically translate this graph so that the entire graph, all the y values are 0 or negative. I forgot to write the below part. And I can't change color for some reason. Hold on, I'm gonna close this and I'm gonna open it up again. Okay, so hopefully you can see that right now the range is 5, like the y value is 5 or lower. And I want to move the entire graph down enough so that it's either going to be at 0, the y value, or lower. So, you know, I could move this down like 100 units, and then obviously the whole thing would be below, which is why they ask you for the possible values of c. So c could be 5. Because if I move it down 5, then the maximum is going to be at 0, which is, well, we're okay with that, because we can have it equal to 0. Or it could be more, right? Like I said, oops. I kind of wrote this wrong. less than -5. There you go. So if we have -5, it moves it down, and then the maximum is at 0. So it's satisfied. And then obviously the rest of it is below 0. And C could be anything less than -5. It could be -6, because that means you move it down 6. And if you were to move it down 6, then the whole thing is below the x-axis. So hopefully that makes sense, the way that I explained this. If you want to, you can just shove this all in a graphing calculator so that you can visualize it better. So here's the f, and then if I put a negative in front, like I said, it's going to turn the parabola upside down, flip it across the x-axis, and you can see if I just move the whole graph down 5 units, then the y values will be negative or 0. So C is -5 or less. Okay. Next question. Question 6. Should I be... Okay, this is the last of section A of the short answer questions. How am I doing for time? Half an hour. Oh, not bad. Okay. All living plants contain some isotope. Okay, whatever. When the plant dies, isotope decays. Okay, you measure the isotope. Okay. Here's an equation to measure the carbon. Okay, show at the time of death, the plant is defined... Oh wait, at the time of death, the plant is defined to have 100 units of carbon-14. T represents the amount of years after its death. And then you need to show A0, A0 is 100. Okay, easy enough. At the time of death means T is 0. So what we do is we just plug in 0 into here, and that's easy enough to do. So we know that A0 times e to the power of -k times t, which is 0, should be equal to the amount of carbon in it. So at the time of death, we know there's 100. This is to the power of 0, so this is 1. So A0 is 100. Okay. The time taken for half of the original amount of carbon-14 to decay is known to be this many years. Show that k is going to be this value. Okay. So we know that if we start with 100, which is A0, e to the power of -k to the power t, and if I were to plug in the half-life, this is the time it takes to decay half of it. So after the first 5,730 years, if I started with 100, I should end up with 50. And then from here, we solve for k. Another way you could do this is because they tell you what the value is, you could plug in k in here, and then if you calculate it out, you should get 50. But I like doing it this way. But it does require a little bit more knowledge to make it the way that they want it to look. So we divide over the 100. Obviously this is going to reduce to 1/2. And then we change this into log form. So this is natural log because it's base e of 1/2 is equal to -k 5730. And then of course what we do is we take the natural log 1/2, we divide the -5,730 over, and we're almost done. Notice that they want natural log 2 and it's a positive. So what we do is we take this negative, right? It's a -1. Dividing by -1 is the same as multiplying by -1. So we move the negative up top, and then we can use log rules to take this -1 as an exponent inside our logarithm. So we have natural log negative, well, 1/2 to the power of -1. And then knowing your exponent rules, the negative exponent takes the reciprocal of the base. And then you're done. Okay. Again, the other way you do this is if you were to assume that k is this value. I don't know where to write this. Here. So we plug in this value for k. So if I assume that this is k, if I were to plug in this many years for t, this should be 50. And it is, because of course these would cancel. And then you take the -1, you bring it in. To here. I'm running out of room. I'm gonna write here. Then you'll have e to the power of a natural log 2 to the -1. And then again, if these are inverses of each other, so what you would get is 100 times 2 to the -1. The base e and then the exponent natural log kind of cancel, sort of, because they're inverses, and then you'll get this. And this, again, well, that's negative, so that turns into 1/2. 100 times 1/2 is 50. Anyways, either way, you have to bring in this negative to change it to a 2. Okay. Find correct to the nearest 10 years the time taken after the plant's death for 25% of the carbon-14 to decay. Okay, so please don't just take this number, which is 50% decay, and divide it by 2. What we're gonna do is, now that we know what k is, we can just figure this out. 25% to decay, right? So that means if you start with 100, you end up with 75. Please be careful with the wording. 25% decay means you would have 75 left out of 100. And then we got e. We know that this is natural log 2 over 5730. And then we want to find t. And then for here, we solve for t. And then there's a lot of ways to do this, but you got a GDC, right? Use the equation solver. You can even graph this if you want, which is what I'll do. So I'm going to graph this side with my variable t, which will be x. So 100, and then where the heck is e? E, k, natural log 2 divided by 5730, okay, times x. Okay. And I'm going to change my window because we are interested for when this is going to be 75. So my x maximum, I'll just change it to 100. Or whoops, that's my y maximum. And then my x values are my number of years. So notice that like half-life happens at like nearly 6,000. So I'm going to change this to at least 6,000. And we'll see what happens. Where's my graph? Did I put this in right? I don't know, it looks like I did, but where's my graph? I have no idea where my graph is. Okay, we're gonna... I hate GDCs. I wish we could just use like smartphones. I'm gonna go Desmos. Oh crap, I can't type right now. Okay, hold on. I'm gonna unplug my writing pad, because hopefully it's been charging for the past half an hour. I'm gonna plug in my keyboard so that I can type. Okay, so 100 e to the power of natural log 2 divided by 5730, I think was the half-life. And then x. Okay, and then zoom out. Oh, no wonder. I think I forgot the k, or the negative in my graph. Insert negative graph. There it is. Because, yeah, right, the formula is negative k. Okay, so here's negative k. We are interested for when this is 75. So I can graph just the horizontal line at 75. And then I can calculate the intersection of these two. So just follow the instructions of your calculator. And then here we go, 2,378 years. And then they say rounded to the nearest 10 years. So we're gonna round this up to 2380, 2,380 years. 2,380 years. Okay, now we get onto part B, the long stuff. So let me copy this. Okay. I didn't want it like that. No, I don't want to save the screenshot. Okay, let me, hold on. Screenshot it again. Copy, paste. All right, we're on to the long stuff. I think there's like 3 questions that are, you know, around 15 marks. So let's see what we got. Windmill rotating around like this. We got radian angle here. Okay, given point A is 12 meters from the base of the windmill, find the height of point C above the ground. Okay, that's easy enough. We want to find the height of point C. This is a right triangle. We have an angle and we have a side. So we can just use regular trigonometry for this. So I don't know, I'll call this h. So h divided by 12 is gonna be tan 0.6, because this is the opposite side. This is the adjacent side of my angle. Therefore, the height of point C is going to be 12 times tan 0.6. Okay, so just make sure that you are in radian mode when you put this into your calculator. 12 times 10.6, 8.21. So this is 8.21. An observer walks 7 meters from point A to point B. Find the angle of elevation of point C from point B. Okay, so the person walks closer, and what happens is they create, you know, a narrower right triangle. We already know from part A that this is 8.21, and then, well, it's 12 meters total distance from A to the windmill, and then they've walked 7 meters closer. So that means that this is, what's 12 minus 7? 5? and then they want you to find the angle of elevation, this angle. All right, so that's just arctan or inverse tan. So we can do that in a calculator real quick. There, 1.02. Okay. The person keeps walking until they are directly under point C. The observer has a height of 1.8 meters, and as the blades of the windmill rotate, the end of each blade passes 2.5 meters over his head. Find the length of each blade of the windmill. Okay. So you got the person. Which is 1.8 meters. It's a male. Sure, whatever. Then you have the blades. So the blades, well, okay, let's add the tower first. The tower is, what did we say it was? 8.21. And then you have the windmill blade. And the windmill blade is obviously connected to the top of the tower. And at the bottom, they say that there is a distance between the end of the blade and the person of 2.5 meters. So this right here is 2.5 meters. And we want to find the length of red. So that's easy enough to do, right? We just take 8.21, take away 2.5, and take away 1.8. .21 minus the green, 2.5, minus the other blue, the height of the person. So 3.91. Now, one of the blades is different, painted different. Why? Okay, whatever. This one is D. Okay. It can be modeled in this function, P, Q, whatever. When T is 0, D is at its maximum height. Find the value of P and Q. Okay, so P is related to our amplitude. Q is the midline of your wave. So basically, you know, at the beginning, point D is at the top, and then as you rotate, you know, the point is going to go lower, and then it goes around in a circle. So if you were to graph these points, it would make a wave. Anyways, the midline of a circular motion is going to be the location of the center of the circle, which we already have. It's 8.21 because, again, they're connected here. So Q is 8.21. And then A is related to your amplitude. What I mean by that is it's going to be the same numerical value as your amplitude. This is your amplitude right here, which is the length of the blade, 3.91. However, it could be positive or it could be negative. And that depends on the other pieces of information. They tell you that at the very beginning, D is at its maximum height. And we also know that this is a cosine graph. Therefore, we don't need a negative because a positive cosine graph will start at the maximum. If they had said, you know, point D at the beginning is the bottom blade, then we would need to put a negative here so that, you know, this properly makes the right graph, because the blade would start at the bottom. So when you graph it, it would go bottom to top and then back down again. But anyways, so here's P and Q. Now, if the observer stands directly under point C for 1 minute, point D will pass over his head n amount of times. And then we need to find the value of n. Okay. So we need to find out how many times this thing is going around. And that is related to here. So this is our horizontal compression. And, well, a cosine has a period of 2 pi. And if we were to compress it by 3 pi over 10, then we are going to divide by 3 pi over 10. And then, you know, dividing by a fraction, you can flip and multiply. Pi's cancel out. And then you got 20 over 3, which is, what, 6.67? Right? Okay. So this is how long it takes Hold on. Let me just double check my variables here. What is t? Is t in minutes? I think t is in minutes. Okay. Okay. So this is my period. It takes 6.67 minutes to go around the blade once. So if you're standing here, and then it starts here, if you rotate 1 minute, that's not that much. Like, that means you only rotate like this much. So, point D, is it gonna pass over the head at all? I don't think so. Okay, something's off with this. So, let's look at our answer key. Rotations per minute, 60, their period. Okay. Something is up with this. Oh, that's why. Man, I need to read. Shoot. T is in seconds. My bad. That means that the period is in seconds. So it's gonna rotate a lot in 1 minute. Okay, so rotations. Well, in 1 minute, right? Well, that's 60 seconds. So we now divide by how many seconds it takes to rotate. So 60 divided by 6.67, 8.99. Okay. And then I don't know how pedantic they are. So here you are, right? You're a person. So you are going to go once, twice, basically almost 9 times, right? And if I look at the answer key, they say 9. And I think that's really stupid. Oops, let me reopen that just for future reference. And what I mean by that is it's saying how many times does the point D pass over their head. And if you're only counting from the bottom, yeah, it's 9 times, but shouldn't you be counting when it passes over their head from the top too? So is the answer key wrong? Shouldn't this be 18 or 17 if you don't count, if it's because it starts at the beginning, you don't count that first one? Whatever, let's just say it's 9 times. That's kind of dumb. Okay, 2 more, right? 2 more. How long has this recording been going on for? Over an hour, shoot. Okay. Let's hurry this up. Flight times, T minutes. So minutes. 2 cities can be modeled normal distribution, mean of 75, standard deviation of a sigma. Okay, we don't know sigma. We'll probably need to find sigma, which means we'll need to standardize this. Given that 2% of flight times are longer than 82 minutes, find the value sigma. Okay, so here we go. So whoop. Okay, so here is the normal distribution with this 2% probability added in. And again, whenever you don't know the mean or the standard deviation, we standardize the normal distribution. So we're going to standardize this. So this is T, we're going to standardize it to Z. And then the reason we do that is it's the same area, but our Z score is going to be 82. And then this is always the formula to transform the Z scores. You take your boundary, you subtract the mean, which in this case is 75, and then you divide by the standard deviation. Okay, now the reason we can do this, or the reason why we do this, is we can use a calculator to actually give us the value of the Z score using inverse norm. Okay, so we're going to go to, I think, yeah, second, go to the distribute function, inverse norm, and then, this sucks. It's gonna ask for the area, and if you have like a lame calculator like this, inverse norm is for an upper boundary. So if you notice, this is a lower boundary. So what we do is we just take the complement, and sorry, this should be 0.02. We're going to inverse norm the other side, this side. It's the same thing, right? It's just what your calculator can calculate. Mine, unfortunately, can only find an upper Z score. So my area is, well, 100 minus 2%, so 98%. And then this is why we standardize, because a standardized normal distribution, we always know that its mean is 0 and its standard deviation is 1. So we can always find a Z score if we know the probability. So this Z score is 2.05, whatever. So what did I say it was? 0.537, blah, blah, blah. And again, this is this expression as well. And from here, you can just find out what sigma is. What's 82 minus 75? 7? Okay. So this is 7, and then just switch these two if you want to find out sigma. Okay, so here's you can literally just do 7 divided by answer. I'm gonna do the answer divided by 7 and then take it to -1, which does the inverse. I think it's just faster, but whatever. Either way, just divide the two. And here's your standard deviation, 3.41, 3 sig figs. Okay, now find the probability that a randomly selected flight will have a flight time of more than 80 minutes. So now that we have a standard deviation, we can start using the other distribution stuff. So more than 80, right? But again, we know its average is 75. And now we know its standard deviation is 3.41. And then we can just use your calculator for this. Norm CDF. And I want to find out when it's more than 80, I think. Yeah. So my lower boundary is 80. My upper boundary, I don't have one, so we're just gonna choose a large number. Oops, that's not that large. There you go, 10 to the power 99. 75 is my mean, and my standard deviation is 3.41. So there's my probability, 7.1213%. So 0.0713. So this is the probability that your time is more than 80. Okay, next, given the flight between the two cities takes longer than 80 minutes, find the probability that it takes less than 82 minutes. Okay, so find the probability that it takes less than 82 given it does take more than 80, right? So this is conditional. We can just follow the formula. And then we want the intersection of these two. So more than 80, but less than 82, right? So we can just write it like this. So that's the intersection of these two. We know this from an earlier part. That's going to be this number. And then this, we just have to do our norm CDF calculation again, but now we have an upper boundary. Okay, so I'm gonna do that again. So now I have an upper boundary, it's 82. Paste it. And then I'm gonna take this, and then I'm going to divide it by my answer from before. Because my answer from before was the probability of it being more than 80. There you go. 0.7 whatever. 19. And then I guarantee you, I haven't even read this part, but it's going to turn into a binomial distribution. On a particular day, now there's 64 flights. So now if you have multiple trials, multiple flights, it's a binomial distribution. Find the expected number of flights that have a flight time of 80 minutes or more. So we want to find the expected value, I don't know, we can say x, which is the number of flights that take longer than 80 minutes. Expected value of x, this is n times p. What did I say there was? 60 flights or something? Why would they do 64? Just give me a nice number. Whatever. 64 times the probability that one flight is going to be more than 80 minutes long, which we found out again earlier. Okay, clear it out. 64 times 0.0713. So you should expect this many flights to take more than 80 minutes. It's an expected value, so you don't need to round it, even though like this x is counting the number of flights. It's an expected value, so we keep the decimals. You don't need to round it. At least I'm pretty sure. Okay, find the probability that more than 6 of the flights on this particular day will have a flight time of more than 80 minutes. Okay, so now we are finding the probability that 6 out of our 64 flights are going to take more than 80 minutes. This is a binomial distribution. It's not cumulative. This is a PDF, not CDF, for those that are using a TI, because we are interested in exactly 6, not like at least 6. So then that would be 6, 7, 8, 9, 10, all the way to 64 flights, which is a cumulative thing because you would add them all up. This is just a normal one. Okay, so distribute binomial PDF. We have 64 flights, those are our trials. The probability of an individual flight taking more than 80 minutes, we already know that from before, and we're interested in the probability that 6 of those 64 flights will take that much time or longer. Okay, there you go. 135. Okay, and then we're done, I think. Right? Yeah, we're done the question. And then there's one more. Copy, paste, and what's my time at? Oh, okay. It's been 1 hour and 12 minutes. So even with this kind of slow explanation, I'm below the 1 hour and a half mark that you would get on your exam. Okay, local lottery. The cost's $2. Okay. The probability here, for example, the probability of a person receiving $10 is this. Grand prize is this. Okay. So this is your payout. And then this is the probability. Okay. So first off, determine the value C. This is the probability, the total probability. So this should always be equal to 1 if you were to add these all up. So we can pretty easily find out what C is from here. We would just take 1 and subtract these guys from it, which is what I'm gonna do. 1 minus 0.85 minus 0.03 minus 0.002 minus 0.0001. And then there you go, 1179. I'm just gonna check if they want you to round it to 3 sig figs. Because this is technically an exact value, but it's not, but it's 4 significant figures. Oh my god, the answer key is not loading. Okay. Here, you can see it too. Okay, because it is an exact value, like the decimal ends, they are okay with you keeping it. Okay, next up, determine whether it's fair. So a fair game means that your expected value is going to be, well, first off, a fair game means no money lost or won. So because you paid $2 for this, your expected value should be $2, which means that you haven't gained or lost money. And expected value would be, we're going to calculate that out right now. You know, it's the dollars that you would win times the probability of those dollars, because your expected value is, well, how many dollars you get. So we will do just that. I'm gonna write this in green right here. So for the sake of things, I'll actually write it out. You got 0 times 0.5. You got 2 times C. And again, we know what C is now. 10 times 0.03 plus 50 times 0.002 plus grand prize. Grand prize is $1,000. That's so stupid. Why would they do that? Why would they say grand prize and not just say $1,000 here? That's just gonna stress you out because you're gonna see how much is this, and then you'd have to force yourself to read this. I mean, I guess you should be reading it in the first place, but okay. So we got 2 times 0.1179 plus 10 times 0.03 plus 50 times 0.002 plus 1,000 times 0.0001. So your expected value is this much. Actually? Damn. So, not fair. This means because you're paying $2 and on average the game is going to award you 73 cents, it's not fair. You're not earning back as much money as you spend on it. Okay, nobody wins the grand prize in the first week. That means the probabilities stay the same. But the grand prize is going to be 2,000. And then it'll continue to double until you win. All other prize amounts are going to stay the same. Given the grand prize is not 1 and it continues to double, write an expression in terms of n for the value of the grand prize in the nth week of lottery. Okay. So it's $1,000, right? And then basically we're doubling this for every week. So n minus 1. You have to be careful. It needs to be n minus 1 because, well, you know, on the first week, you shouldn't be doubling it. So this needs to be 0. So there's your formula for the grand prize. Now, the Wth week is is the first week which the player is expected to make a profit. Ryan knows that if he buys a lottery ticket in this week, his expected profit is P dollars. Find the value of P. Okay. Wow, that's a loaded question. So first off, you need to find out when he's going to make a profit. That means that first, you need to find out how many weeks before it breaks even. So you need to find out how many weeks the expected value is going to be $2 first. Because after it goes past $2, then you're making a profit. And then that's going to help you find W, because when you find W, you can plug it into this formula to find out what, not this formula, but the expected value formula, to find out what his expected profit is. So hopefully that makes sense, what I just said. So here is my expected value formula. Except one thing is changing. And that is the last term. Because the grand prize is no longer 1,000, right? It's 1,000 times 2 to the power of n minus 1. Okay. I'm gonna just simplify this a tiny bit. I'm gonna add together these 3 terms, and I can multiply 1,000 with this decimal, which is 10,000. So let me go back to here, and then I'm going to just delete this. Okay, so I'm just adding up the first 3 terms of the expected value, these 3. So 0.6358. Okay. And then 1,000 times 10 thousandths is, well, I think it's like a tenth. Here. Yeah. So I'm multiplying these 2, that's 0.1. I've basically copy and pasted these three, this one, and this one to get that one. Okay, and we want to find out when this, which is still, this is just a simplified expression for the expected value. We need to find out how many weeks it takes for this to be 2. And then again, lots of ways to do this. You can algebra and use logs. You can graph this. It's up to you what you want to do. I'm going to algebra. So subtract this from it. Here, I'll just show the work. So that goes over there. So we got 2 minus 0.6358. So we got 1.3642 divide by 0.1 divide by 0.1. So this is going to become 13.642. Let me just double check and make sure that I'm doing that math correctly. Yep. And then from here, we can change this to log form. So n minus 1 is log base 2, 13.642. Evaluate this log. So log base 2, 13.642. And then if you poor souls have like a TI-83 that can't choose the base, you'll have to change this to base 10. So then it would be like a regular base 10 log, this button, of 13 divided by log 2. Just follow the change of base formula. Okay, and then you get that decimal, 3.7 whatever. And then we add 1, so it takes 4.76. Okay, and then you gotta think about this, right? The expected value will be 0, so you won't be making a profit. You'll just be earning back, breaking even, making the money you spent after the 4th week, but before the 5th. So that means that profitable, let's say, is going to be the 5th week. So when n is 5. I think they called this W though. Yeah, the Wth week is the first week which you're expected to make a profit. So the first week you're expected to make a profit is, well, the next whole number, which is 5. Okay, now we need to calculate the expected profit. So now we take this whole formula for expected value, and now we know that n, which is W, is 5. Okay, plug this all in, and then you're done. And then I think you're done the exam. Let me see if I can just cheat and copy from above. This one. Okay. So here's that 1000-bit, and then I'm just gonna multiply this by 2 to the power of 4, because 5 minus 1 is 4. And then, whatever. I'll just multiply this at the end by 0.001. And then I'll get 2.2. Well, 2.2. Should I write the whole thing? I don't know. I'm just gonna... Yeah, you know what? I'm just gonna write the whole thing. And then if you want to round it to 3 sig figs, then you can round it to 3 sig figs. Okay, I think this is it, maybe? Yeah, sure. Okay, let's just go over the answer key real quick here. So I don't think I can show you both screens at once, so I'll just let you know. I got the A right, I got the B right, I got the R right, but that was just reading it off the calculator. A, waiting time per customer. Okay, they say it represents the average increase because, you know, it's going up. It's a positive correlation of waiting time per customer. So I guess you gotta be more careful with that. 8.52 minutes, easy. Okay. Yeah, sketch the graph. Okay. Recognizing this tangent derivative 0 is at the maximum. The maximum is at 2.33. Yep. Okay, K is 25. Yep. The maximum is 750. Yep. Okay, Venn diagram. We got 8%. Yep. Part B, we got 12%. Yep. I looked at the answer key for this one. This was the weird conditional one. Justify your answer. Yeah, obviously these two are not the same thing. So it's not independent, so they're dependent. Yep. Okay, range. Yep. Composition. Blah, 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 blah. This is correct. This was showing this was 100. I think we showed that somewhere. Okay. Show that K is this. We also showed that, so then that's fine. And then lastly, 25% carbon decay, right? So 2,380 years. Okay, that's done. Okay, 8.21 for C. Then next up was angle, 1.2 radians. Yep. Okay, next up, finding the length of the blade, 3.91. Yep, that's right. Okay, P is 3.91. It's the length of the blade. Yep. Q is 8.21. Yep. Okay, and then right, I talked about this one. They say 9 times because it rotates 9 times, but they're not counting when it passes over their head on the top. And I messed this up because T was in seconds. So this was in seconds, therefore 60 seconds divided by that is where you get the 9 rotations from. Okay. Okay, standardizing, standard deviation 3.41, yep. Putting this in a calculator, 713. They use 712. I don't know, that's probably some rounding error somewhere. Conditional probability, this one's right. Expected value, yep. When x is 6. Oh shit, okay. Remember how I said that this wasn't cumulative because it doesn't say more than? It does say more than. So let me just do this real quick. You're supposed to do this. X is more than or equal to 6. Okay, so this is a lower boundary. Binomial CDF, which is the cumulative one, is an upper boundary. At least it is for TI. So what you would do is you would take the complement. So this is 1 minus x less than 6. And then of course, being less than 6, because this is counting planes, is less than or equal to 5. My bad, my bad. Read the question, you guys. Very important for those that are still here at the end of this. Okay, and then this is easy enough, right? We would just binom PDF this one, get a number, and then do 1 minus, so that we get this one. Whatever. Okay, moving on. 1179, yep. Not a fair game because of the payout, that's fine. Okay, 1000 times 2 to the power of n minus 1, yep, that's right. And then the last one, again, recognize that this needs to be more than 2, so first we find out when it's equal to 2, which is 4.76. Yes, so then you need to make sure that you take this to the 5th week. And then here's the expected payout. Oh, and then they, so stupid. Okay, this is the payout, right? But we want expected profit. So you had to pay $2 for this, so you're supposed to take away $2. So this is your expected profit. Tricky. Oh well, overall, I got a 7. I mean, I'll always get a 7 for SL tests. But yeah, I really shouldn't have made that cumulative mistake. But that's because I read it wrong. And then this one here, the intersection, this one was a little tricky. Yeah. Oh well, okay. Thanks for watching, guys. This was a long one. And who knows when I'll be back, because, well, I'll probably be back after the 2022 exams come out and that I can go over them. Until then, I don't know. I'll see you when I see you guys.